Welcome to class today. Today I'll be doing a brief tutorial on the chemistry practical for your NECO exams. Now I want to say this very quickly. For some of you in your WAEC exams, you didn't really do the practicals very well because I'm aware of some changes that occurred in the chemistry practical for WAEC. Are you with me? There were many students, what they were expecting was not what came out in the exam, and eventually a lot of students were destabilized. So this is another opportunity for you. All right, so if you have made a mistake in your WAEC exams, this is a second chance. This is another opportunity for you to make right those mistakes in this NECO. So if you're writing this exam, I want to congratulate you because you have another opportunity to do the right thing. Number two, for those of you that actually did the right thing in your WAEC, it's another opportunity to also get it right again. So please, if you made any mistake in your chemistry practical in the WAEC exams, these NECO exams, try your best to practice as many questions as possible. I know you might have seen some questions online, but the more questions you practice on this acid-base titration, the better prepared you are for the exam, so that whatever kind of question that comes out, you know exactly what to do. So today I'll be dealing with two questions. If you see questions like this, so you know exactly what to do. Now, if you have not seen my video on how I got my titer value and all of that, you can check it out. I did a video on that. I'm not going to be doing that now. I will just use the titer value from the first video, and then I will use to do the calculations. Now, let me also say this. Now, the major reasons why you are carrying out your practical, the acid-base titration, is to get the average titer value. So once you have the average titer value, you don't need to waste time. Just go ahead and answer the questions that are being given. One of the mistakes that some students make in the WAEC exams was that, okay, even though they change the question and all of that, but even at that point, they expect you to make use of what was available right there. Carry out the experiment, use the titer value, and do your calculations. Because the report that your teacher would have given to them is exactly what they're going to use to score you. Are you getting what I'm saying? So next time, if you have such situation, do not get destabilized that, oh, we were expecting H2SO4 and this, and then now we are getting this. They can decide to change it. But whatever your teacher had provided, are you getting me? And then the report he has given is titer value and all of that. That is what they are going to use to judge you. So don't be scared. Is that okay? Don't be scared. Just go straight. Whatever your teacher has provided for you, make use of it, get your average titer value, and you might even be fortunate to have the range of your titer value given to you ahead of time. So if you have that range, all you need to do is you can just do a round of titration, confirm that, okay, that's your average titer value falls within that range, and you shoot straight to the calculations, because this is the most important part of that acid-base titration. Getting your endpoint, which is your titer value, is important, but also you need to get all of these right as well. Now, here is a question on the board. A is a solution of tetraoxosulfate 6 acid. B is a solution containing 4 grams of sodium hydroxide per dm3. Please pay attention to all of this. So that means our A is tetraoxosulfate 6 acid. Our B is sodium hydroxide. In your question, the first question that could come out, they can ask you to write a balanced equation for this chemical reaction, for this acid-base reaction. And in some cases, they could provide the balanced equation for you. They can also write the equation and ask you to balance it, or better still, they can write the equation before you start solving. Inspect the equation and be sure it is balanced before you continue, because you're going to need that balanced equation in your calculation. So let's quickly write the equation. So whenever an acid reacts with a base, the product is going to be salt and water only. So here the acid is H2SO4, tetraoxosulfate 6 acid, H2SO4 plus sodium hydroxide, and then it's going to give us, so in case you don't know what the product will look like, whenever an acid reacts, it will ionize to give hydrogen ion. and then SO4 2 minus, so it ionizes. Then the base is a substance that ionizes to give hydroxide ion as its only negative ion. So this base will ionize to give you Na plus OH minus. So the acid is a substance that ionizes to give hydrogen ion as its only positive ion. So the positive and the negative here will react. You remember, like poles repel or like poles attract. So the negative ion here will attract to this, and then the positive here will attract to the negative. And when they attract, they will exchange their oxidation number. So the oxidation number of sodium here is +1. This plus 1. SO4 2 minus means the oxidation number is 2. So when the two of them are reacting together, they will exchange their oxidation number. So when they exchange it, so the product will be Na2SO4 plus this and this will give you water. So this is the salt, this is the water. Mind you, if this product is not correctly written, if you write NaSO4 here, you are wrong. A lot of students will write NaSO4. There is nothing like NaSO4. It is Na2SO4. And if you wrote NaSO4, your equation will not be balanced. The number of mole of acid and base will be wrong, and everything you have calculated will be wrong. So even if you know the answers, you know the right thing to do for each step of your calculation, if you make your mistake from here, and then your number one, you will waste time trying to balance this equation. It will not be balanced. Number two, your number of moles of acid and base will be affected, and it will render all your calculations to be null and void or wrong. Right, so you don't want to make that mistake. So now that you've gotten this, so you might need to pause this video if you don't know how to balance equation, and watch this very well and know how to balance it. So here we have sodium, 2 moles of sodium on this point. All right, 2 moles of sodium. So I'm going to come to this side. I put 2 here. So I have 2 sodium, sulfur here 1 1. All right, oxygen here 4 plus 1 5, oxygen here 4 plus 2 6. So I need to add one more oxygen here. So I'm going to put 2 here plus, this is a plus. All right, I'm going to put 2 here. So now I have 2 oxygen plus 4, that is 6 oxygen. Here I have 2 plus 4, 6 oxygen. And if you respect the hydrogen, it's balanced. 2 hydrogen plus 2 hydrogen here, that is 4. And 2 multiplied by 2, that is 4. So now our equation is balanced. So from this balanced equation, the number of mole of acid is 1 mole, number of mole of base NB is 2 moles. Now for this is correct. So now you can now proceed to answer the questions that have been given. So there is a mark. If they ask you to write a balanced equation, there's a mark for this, and then you can go ahead to answer the next question. So the next question says, put A into a burette and titrate with 25 cm³ portion of B. This is your volume of B. So, but before we go to the volume of B, what are the other parameters that we were given? B is a solution containing 4 grams of sodium hydroxide per dm³. Please pay attention. This is grams per dm³. It means the value for the base that was given is mass concentration, because this is grams, so it's mass. So the mass concentration of B is 4 grams of sodium hydroxide per dm³. It means 4 grams per dm³. That is the mass concentration of B. What else were you given? So they said put A into a burette and titrate with 25 cm³ of B. So that means the volume of B, volume of base of B is 25 cm³. So in the question, they can tell you either 20 cm³ or 25, depending on the size of the pipette in your school. But most schools are going to be using 25 cm³ for the volume of the B. While the volume of your volume of acid, that's volume of A, is the average titer value that you got, which is the volume of acid used. Is that okay? So for my calculations here, I will be using 27.50 cm³ as my average titer value. Now let me say this, let me sound this note of warning. Please don't try to master or don't try to cram average titer value that you find online. Some of you made that mistake in your WAEC exams. I told you at the beginning, this is another opportunity to get it right. If you master or you cram average title value from the one you found online and you use it straight in your exam, you will be wrong, because your teacher had carried out his own experiment based on the reagents, based on the compounds that were given to you, and he has given his own report, and the exam is going to be marked based on that report. So if your title value is very far from what your teacher is written or has written down as a report, then you will be marked down. So the reason why those online classes, yes, they are very good, they help to prepare you, but please don't cram their average title value. Rather, try to carry out your experiments in your school and get your average title value. And if your teacher is he could actually give you a range, okay, a range of where your average title value should fall. Please work with that, it's safer for you. All right, so for me, my own title value is 27.50. It may be different from that of your teacher. It may be similar, I don't know. So, but once I get this average value of acid use, which is my average title value, the next thing says tabulate your Burette reading. So I've done another video on the table, how to get your table, all right, how to tabulate. I've done a video on that, and then you can check the video just after now, and calculate the average volume of A used. Now from your results, calculate. Okay, since I already have my average title value, let me just give you a clue of what the table looks like. So your table, I'm giving you an acronym B5. What is B5? B5, B stands for Burette reading. Burette reading is CMQ. Then final reading in CMQ. Then you have initial reading in CMQ. B5, BFIV. Then volume of acid use. Average volume of acid use. All right, so you tabulate it something like this, and then you can have 4 columns here. You have your rough, your first, your second, and your third. So this is how your table should look like. Okay, so this CM since you have already written it here, it may not be necessary for you to put it here again. It means all my final reading are in centimeter cube. So now I told you, so since I have gotten, after doing my titration, I've gotten this as my average title value. So what you want to do is, there's a way you can plot your table, or come up with your table that you wouldn't waste time. Just walk around your average title value and you get the answer. What I'm going to do is this. Initial reading here is 0.00. You can decide to make everything 0.00. You can decide to do you can write any value, 10.0, 10.5, but I prefer 0.00. Okay, now make your reading in 2 decimal places. That means after the decimal, 2 places after the decimal. All right, and then because my average title value is 27.50, so all I need to do is I can add this 27.50 plus or minus 0.5. So if I add 0.5 to this, I'm going to have 28.00, and if I remove 0.5 from here, I'm going to have 27.00. So these are the values I'll be working with, because they are within the range of this 27.50. So what I will just do here, I can put 28.00, 27.50, 27.00, then 27.50. Now note, the sum of your volume of acid use and this initial will be equal to this final. The sum of these two will equal to what you have up here. So if you add this here, so you're going to have 28.00. Add this to up, you have 27.50. Add this to up, 27.00. Add this to here, 27.50. So now we want to now get our average titer value. So your average titer value, titer value is going to be the sum. All right, you are going to pick any three. You can neglect the rough. Pick any three from here and divide it by 3. So I have 27.50 plus 27.00 plus 27.50. Or I can decide to put, since I'm trying to work towards 27.50, so let me put my 28.00 here. So I would prefer to use 28.0 here. Yes, 28.00. And then here is 28.00. So by the time I had this and I divide it by 3, my average volume of acid used, my average volume of acid used is going to, if you add all of this and divide by 3, your answer is going to be 27.50 cm cube. All right, so that is my table. So once you have done this, you get your full mark for your table. All right, your centimeter cube, the sum of this and this will give you the final. You use your B5 here, right? And then by the time you are getting your average titer value, pick any 3 with the first to third. All right, and then you divide by 3 and then you get your answer. 27.50. Okay, now I haven't done this. The next thing is, now let's try to tackle the questions that have been asked, that we've been asked, using 27.50 as our average titer value. The next question says, for result, calculate concentration of B in mole per dm³. Remember, we have mass concentration of B because we have been given 4 grams of sodium hydroxide per dm³. Let me talk about this. If a question has said 4 grams of per 200 centimeter cube, so if the question says 4 grams in 200 centimeter cube or per 250 centimeter cube, what you just say is 4 grams in 250 centimeter cube is 250. It could be 500 centimeter, it could be 200, whatever, it could be 100. You just say 4 grams in 250 centimeter cube. You now say X gram in 1 dm³, which is 1000 centimeter cube. 1 dm³. Okay, then you cross multiply 1 dm³. By the time you cross multiply, whatever your value of X is, okay, whatever you get will be the mass concentration. It will be the concentration in grams per dm³, which is this. But the reason why we are not doing that is, look at the question very well. They said B is a solution containing 4 grams of sodium hydroxide per dm³. So per dm³ means in 1 dm³, which is in 1000 centimeter cube. So they have already done all of this, so you do not need to do all of this. Because some of you don't understand. You've seen some videos where they did this. Some of you are saying this now, that I'm not going to do this, and you'll be like, I'm getting confused. You don't have to get confused. The reason is because it's per dm³, per 1 dm³. But if it had been present in or per 250 cm cube, then you have to do this, stay and convert it. Is that okay? Now, so since ours is already in grams per dm³, amount in grams per dm³, we can just go straight. So the first question there, concentration of B in mole per dm³. Concentration of B in mole per dm³. The formula is unknown. So formula is molar concentration equals to mass concentration over molar mass. Molar concentration is equal to mass concentration over molar mass. Please, once you state your formula correctly, there is a mark attached to it. There is something called scoring points in the NECO marking scheme. So the scoring points mean what are the things that should earn you marks. So your formula that is correctly spelled out will give you a scoring point. Molar concentration is in mole per dm³. Your mass concentration is in grams per dmq, which is what we already have. Molar mass is in gram per mole. All right. So for us to now find the molar concentration, we just divide. So our answer is going to be, what's the mass concentration? 4 grams per dmq divided by molar mass of what? Of B, which is sodium hydroxide. So let's quickly calculate it. NaOH, sodium is 23, oxygen is, molar mass of oxygen is 16, and hydrogen is 1. So 23 plus 16 plus 1, that's going to be 40. So the molar mass, so the molar concentration of 4 over 40, which is the molar mass. So what's 4 divided by 40? It will be 0.1 mole per dmq. Please take note of the units. The units will be marked. If you write a wrong unit, you'll be penalized. Are you with me? If you don't know the exact unit to write, you might just write the answer and leave the unit. But these things are very simple. If you have practiced them, okay, you can get exactly the correct unit. So because we are looking for molar concentration, the unit is mole per dmq. So the molar concentration of sodium hydroxide is 0.1 mole per dmq. The next question says concentration of A in mole per dmq. So concentration of A, how do we get the concentration of A in mole per dmq? It is very simple. Since we already have volume of B, we have volume of A, we have C of B. That's molar concentration of B. So the formula we're going to use will be CAVA over CBVB equals to NA over NB. And we are trying to look for concentration of A, CA. So we cross multiply. So we are going to have CAVANB equals CBVBNA. Divide both sides by coefficient of CA. That's VANB. This cancels this. So our CA is going to be CBVBNA all over VANB. So let's slot in those values. What is our CB? Means molar concentration of B, not the mass concentration. All these are molar concentration. This CC. Okay. So the molar concentration of B is what? That is what we have solved. There 0.1 times the the volume of base is 25, always 25, times number of mole of acid, Na is 1, all divided by VA, volume of acid is our average titer value, which is 27.50. 27.50 multiply the number of mole of base is 2. So this is going to be 2.5 divided by 56 or 55 rather. 2.5 divided by 55, because this 27.5 multiplied by 2, it will give us 55. Yes, 55. So if you punch this on your calculator, the molar concentration of A, which is what we are looking for, which is the same as concentration of A in mole per dmq, is divide 2.5 by 55, your answer is going to be 0.0454 mole per dmq. So because we were asked to find the concentration of A in mole per dmq, that is your answer. The next question says number of hydrogen ions in 1 dm cube of A. Number of hydrogen ions in so let's quickly solve that as well. The third question says number of hydrogen ions in 1.0 dm cube of A. So number 3, we were given 1 dm cube of A. So the volume of the acid in 1 volume of acid, the volume is 1 dm cube. You remember the molar concentration of our acid is what? 0. So our Ca is 0.045 mole per dm cube. Now they're asking us the number of ions or the number of hydrogen ions. To know that is very, very simple. According to Avogadro's law, it says 1 mole of any substance has 6.02 times 10 raised to 23 atoms or particles or ions, right? So if that is the case, all we need to do is to find the number of mole from here, convert this to number of mole, and then you equate it to this. But before you continue, if you recall, H2SO4, if you ionize it, it will give you H plus SO4 2 minus. So there are 2 molecules of hydrogen here, so we are going to have 2 here. Okay, so 2 and they are asking you what is the number of hydrogen ions or particles here. So the first thing, this H plus is hydrogen ion concentration. So the first thing you want to do is to multiply the concentration here by 2. So you're going to have 2 times 0.0454. All right, you multiply by 2, then you multiply it by 6.02 times 10 to the power 23. How do we do it? Or you can do it one step at a time. This by this is going to give you what? To give you 0.09. 0.09. All right, 0.0908. 908. Yes, 0.0908 mole. Because number of mole is what? Molar concentration times volume. They said in 1 dm³. All right, so the next thing you want to do is you now use, since 1 mole of a substance is 6.02 times 10 to the power 23 atoms, then 0.0908 mole is going to be equal to x cross multiply. When you cross x times 1, x will be 0.0908 multiplied by 6.02 times 10 to the power 23, and that will give us the value of our number of hydrogen ions. So when you punch this in your calculator, what's going to be your answer? It's going to give you 5.47 times 10 to the power 22 ions. So if the question says how many hydrogen atoms, it will be atoms or particles. And that brings us to the end of this question. That brings us to the end of this question. So please practice over and over again. But I promised also to give a scenario. So let me quickly give you a second scenario and how you go about it, and then you go through everything that is here. Let's look at the second scenario. Now this scenario, the question says A is a solution of tetrasulfate 6 acid, B is a solution containing 4 grams of sodium hydroxide in 250 cm³. So all you just need to do, you don't just go straight and use 4 grams. No, it means 4 grams of B is present in 250 cm³ of solution. So x gram will be present in 1 dm³. 1 dm³ is the same thing as 1000 cm³. So you can write 1 dm³ here and convert this to dm³ by dividing this by 1000, or you can just say present in 1000 cm³, and then you cross multiply. So when you cross multiply, you are going to have 250x, 250 times x, 250x equals to 4 times 1000. Divide both sides by 250. Divide both sides by 250. So your x is going to be, all right, 250 here is 4. 4 by 4 is 16. Now that 16 you are getting will now be what? Grams per dm³. 16 grams per dm³. That will now be the mass concentration of the base. The mass concentration of the base, 16 grams per dm³. You remember I told you another way you could do that is you can say 4 grams is present in 250 cm³. X gram is present in 1 dm³. Convert this 250 cm³ to dm³ by dividing it by 1000. So if you divide it by 1000, so you're going to have 4 grams is present in 0.25 dm³, while x gram is present in 1 dm³. So when you cross multiply, so 0.25x is going to be equals to 4 times 1, 4. So you divide both sides by 0.25. Divide here by 0.25. So when you divide it, our answer is going to be 16 grams per dm³. Because 0.25 times 16 means I'm dividing 16 by 4. So it's going to give me 4. So you get 16. So whatever it is you were given here, just interpret it correctly. If they give you in per dm³, if they say per dm³, it means in 1 dm³. You don't need, then you do it the first way I did it. But if they say in 250 cm³, this is exactly how you're going to do it to get the mass concentration of the base, and from there you can now answer the other questions. I hope this video was quite explanatory to everyone. All right, If you have any question, please feel free, drop the questions. I will be back to give you a response before your exams. I wish you all the best in your forthcoming exam, and please do well to like this video. If you have gotten value, go to the comment section and comment value there. Share this video with your friends, and please, if you have not subscribed to our channel, what exactly are you waiting for? Please go straight and click on the subscribe button. And thank you for doing that, for supporting us, so that we can continue to give you educative content on this platform. Bye for now.